Welcome to talking about switches in our electricity unit. Nice to see you guys. I hope you are enjoying our electricity unit so far. At this point in electricity, we have talked about a lot of different things. It might be our standard circuit with an energy source known as a cell. We have our light bulb and all the different parts like the support wires and the glass globe and the filament and the tip and the thread, all these really important things. But they all have to work together for light to turn on. And we saw that with an early lesson where we had one wire and one bulb and one cell. It has to work perfectly and for that light to work. So we're going to add one more layer because unfortunately we don't want light on all the time. If we're trying to go to sleep, if we're trying to see something on the TV, we might turn the lights off to make it easier to see. But we want to control and not rip the cells out or unscrew the light bulbs to turn it off. We want an easier way that we can adjust it, that at certain times we have the lights off and at certain times we have it on. And that's where a very handy tool known as a switch comes in. Now, you'll notice in my classroom, I'm going to bring you over here real quick, that we actually have a fancy switch. Now these are motion detectors and these are a little bit different. So if I wave my hand in front of it, it notices my reflection or senses my hands there and turns on the lights. That way, if no one's in the room, there is no light. But I can go ahead and there's a little button. Sorry if I'm making you nauseous. If I click on this, the lights in my room go out. And I don't know if you hear a sound. As I click on these lights, they go on and off. Now I could also wave my hands and the lights would also go on. But in your classroom, I know that you have traditional light switches, which is what you probably have at home. And I want to talk to you about what they really do, okay? Yes, that has a fancy kind of sensor to tell if it notices motion, but a regular light switch is just as effective of turning lights on or off. And it is a super simple concept of how to get lights to turn on or off. Now, if I have my standard circuit, now I could have bulbs in parallel or series or cells in all sorts of different methods. It doesn't really matter. But the one really key thing is right now my standard circuit would be lit as long as my bulb is new and the filament's fine and it's screwed into place and the cell has energy. But in a situation that we might want to kind of turn it on and off, control when it lights and when it doesn't, you can actually include a switch. And we're going to look at a switch in a moment. Here's a switch that I've made. I'll bring it up to you real quick. So you'll see that there's two parts that when they connect, they light the circuit. When we slide it down, it is not going to make the bulb light. So we'll talk about this more in a moment. But the real kind of part of a switch is right now our switch is in an on position, which means that it's lighting the circuit. And I can go ahead and I can flick it down to the off position. Hopefully something like this is familiar to you. And realistically, what's happening is my switch, this is just from the side, is in the on position. If I flick it down, it will stay in this off position. And I'll try to illustrate that for you. So now my switch is in this off position. And what happens is there's actually a wire that runs through the back of the switch. And what's really interesting is when it's in the on position, the wire actually connects. And so energy can continue to flow all the way through. When I flick it off, there's actually a break in the energy flow. So, unfortunately, the energy can't just hop between them. There's a break. It turns it into an open circuit. So right now, the energy would not be flowing and our light would not be lit. Okay? When I switch it back on, then this goes back to this position of closing the circuit, allowing the light to turn on. So when it's on, this is solidly here. When it's off, there's a break, and this space is what's causing that circuit not to light. Hopefully that's making sense. When we go up here, we demonstrate using secret language with 2 dots and an open line. And that would be an open circuit in this situation. That would be like this with our switch in the off position. If I turn it on, right, here's my kind of light switch. If I switch it on, it would move down and be a closed circuit, causing our light to continue to light. So to wrap up our video, you might ask yourself, how does this really work? Well, in an example, what I have here, sorry if I'm awfully close, is I have 2 brass fasteners, which are conductors. You've learned about that. We have a paper clip, which is also conductor, which means that energy can pass through these things. And on the back, you'll see some things you're probably familiar with, okay? One is the ends of the brass fasteners. That way they hold in place. We also have a washer here, and the purpose of the washer is to make sure that it's firmly in place and also allowing the energy to go through everything. But most importantly, a Fahnestock clip. And what's interesting is, just like our bulb holder or our cell holder, the wire is going to go into the Fahnestock clip, through the washer and the brass fastener to the other side. When it's connected, it will go across the paper clip, through the brass fastener, into the washer, into the Fahnestock clip, and continue that loop of energy. Okay? So when it's in an on position, the light would light because the paper clip is making contact with the brass fastener. Once I remove the paper clip, then there's a break in the circuit and the energy can't get across, even if it wants to. So this would be an open circuit with the light being off. So some basic materials, but this is very similar to the same thing that's in your classroom light switch, just with some fancier pieces.